Hello everyone, my name is ZHANG YIXUAN, and first I'm sorry that I can't open my camera because my laptop's camera is broken. Okay, let's start. First I will present project 1. The objective of this project is to build a basic MM1Q simulation. Now I will explain the source code. First, the program imports queue. It is used as a priority queue to process events in time order. Next, the program imports random. It generates random arrival times and service types. This line sets the simulation time to 1000 events. This constant represents an arrival event, and this represents a departure event. This line creates a simulation class. Next, it constructor initializes all variables before the simulation starts. This line initializes the simulation clock. Next, creates the event list and creates a waiting queue. These variables records whether the server is busy or idle. These variables define the arrival rate and the service rate. And these variables record the numbers of arrived, departed, and queued packets. This function initializes the event list by creating the first arrival event. And this line calculates the first arrival time. Inserts the arrival event into the priority queue. This function processes one event each time it is called. This line removes the earliest event from the event list. This updates the simulation clock and stores the current event time. This line checks whether the event is an arrival event. If it is an arrival event, the program processes the arrival. So otherwise, it processes a departure event. This line called the departure function. This function processes an arriving packet. It schedules the next arrival and checks the service status. This line calculates the next arrival time, and this inserts the next arrival event into the event list. This line checks whether the server is idle. This changes the service status to busy. This generates the service time. This schedules the departure event. If the server is busy, the packet must wait. This line stores the packet in the waiting queue, and this increases the arrival counter. This function processes a departure event. This line increases the departure counter. This checks whether there are packets waiting. Removes the first packet from the queue. Calculates the waiting time. Records one queued packet. Generates a new service type. Schedules the next departure event. If the queue is empty, the server becomes idle. This line changes the service status back to idle. This function generates the inter-arrival time. It returns a random inter-arrival time using an exponential distribution. This function generates a service time. It returns a random service time using an exponential distribution. This function displays the simulation results. In this project, no statistics are displayed yet because the function only contains a pass statement. This line creates a simulation objective. This line inserts the first arrival event. This loop runs the simulation 1000 times. Processes one event during each interaction. Finally, the program finishes the simulation. Now I will run the program. Okay, this simulation runs successfully, and all events are processed in order. Okay, next is project 2. The objective of this project is to generate random numbers using an exponential distribution and observe the output values. This helps us understand how exponential random numbers are generated in Python. Okay, first, the program imports a random module. This module provides different random number generation functions. In this project, it is used to generate exponentially distributed random values. This line is commented out. If we enable it, the program will generate the same random sequence every time it runs. Since it is commented out, different sequence is produced each time. This line presents a title on the screen. It tells us that the following output values are generated from an exponential distribution. This loop runs 100 times. During each interaction, the program generates one exponential random number. As a result, 100 values will be displayed. This line is commented out. If it enabled, it prints exponential random numbers using a rate of 40. This line also uses a rate of 40, but it formats the output to 4 decimal places for better readability. So this line generates an exponential random number using a rate of 100. The value is formatted to 4 decimal places before being printed. The parameter end prints all values on the same line with spaces between them instead of starting a new line. Okay, now I will run the program. The output shows 100 exponential random numbers. Since the seed is not fixed, the values are different each time the program runs. Most values are small, while a few values are larger, which is a typical characteristic of one exponential distribution. Next is project 3. The objective of this project is to evaluate the performance of one MM1Q by measuring throughput, average delay, and server utilization under different traffic loads. First, the program imports queue. It is used as a priority queue to process events in time order. Next, the program imports random to generate random arrival and service time. Finally, the program imports matplotlib to draw the result graph. These constants represent arrival and departure events. This line sets the simulation to 100,000 events for more accurate results. This list stores different traffic loads for testing. This list stores the simulation results for later plotting. This line creates a simulation class. This constructor initializes the simulation for one traffic load. This line initializes the simulation clock, creates the event list, creates the waiting queue. This variable records whether the server is busy. These variables define the arrival and the service rates. These variables record the arrival, the departed, and queued packets. This variable stores the total waiting time. These variables record how long the service stay busy. This function creates the first arrival event before the simulation starts. This line calculates the first arrival time. This line inserts the arrival event into the priority queue. This function processes one event at a time. This line removes the earliest event from the event list. This line updates the simulation clock, stores the event type. If the event is an arrival, the program calls the arrival function. Otherwise, it processes a departure event. This function generates the inter-arrival time using an exponential distribution. This function generates the server time using an exponential distribution. This function processes an arriving packet. It schedules the next arrival and checks the service status. This line calculates the next arrival time. Inserts the next arrival event into the event list. If the survey is idle, the packet starts survey immediately. This line changes the service status to busy. This line calculates the departure time. This line schedules the departure event. Records when the service starts being busy. Otherwise, the packet waits in the queue. And this line stores the packet in the waiting queue. Finally, this line increases the arrival counter. This function processes a departure event, increases the departure counter, checks whether packets are waiting, removes the first packet from the queue, calculates the packet waiting time, records the total waiting time, records one queued packet, generates the next departure time, schedules the departure event. If the queue is empty, the server becomes idle. This line changes the service status back to idle. This line records when the busy period ends. Records when the busy calculates the busy period. Records the total busy time. Okay, for the results, this function calculates the final performance results. It calculates the throughput and stores the result. Calculates the throughput and stores the result. Calculates the average queuing delay. Calculates the server utilization and stores the result. This function draws the server utilization graph, plots the graph. This line sets the graph title and X labels, and finally the graph is displayed. This line fixes the random seed for constant results, and this loop runs the simulation for every traffic load. This line creates a new simulation object, inserts the first arrival event, and processes simulation events and calculates the final results. Finally, the program displays the server utilization graph. Oh, now run the program. After all simulations finish, the server utilization graph is displayed. We can see that as the traffic load increases, the server utilization also increases. Next is the project 4. The objective of this project is to generate random numbers between 0 and 1 and visualize their distribution using a scatter plot. First, the program imports a random model. It is used to generate random numbers. Next, the program imports matplot. It is used to create and display the scatter plot. This line sets a fixed random seed. It ensures that the same random numbers are generated every time the program runs, making the result constant. This line creates an empty list called index. It stores the sequence number of each random value. Creates another empty list called rand value. It stores all generated random numbers. This loop runs 100 times. During each iteration, one random number is generated. This line generates a random number between 0 and 1. This line is commented out. If enabled, it prints each random number with 4 decimal places. Stores the current loop index in the index list. Stores the generated random number in the rand value list. Creates a scatter plot. Shows the random values and shows the simple number. This line sets the title of the graph. This line labels the y as count. This line labels the x as random value between 0 and 1. Finally, this line displays the scatter plot on the screen. Okay, run the program. We can see that all random values are distributed between 0 and 1. The points are spread across the graph without any obvious pattern, showing that the random numbers generator works correctly. Next is project 5. The objective of this project is to generate random numbers using the LCG algorithm and visualize the generated values with a scatter plot. First, the program imports a time model. It is used to generate an seed based on the current system time. Next, the program imports matplotlib. It is used to draw the scatter plot of the generated random numbers. This function generates random numbers using the LCG algorithm and displays the final scatter plot. This line defines the multiplier used in the LCG formula. defines the increment value used by the generator. Generates the seed using the current system time. Different execution times produce different starting values. This line defines the models. It limits the generated numbers to a fixed range. Creates an empty list to store the generated random values. Creates another list to store the sequence number of each generated value. This loop runs 1000 times. During each iteration, one random value is generated. This line is the core of the LCG algorithm. It calculates the next integer using the previous value together with the multiplier, increment, and modules. This line converts the generated integer into a decimal value between 0 and 1. This line stores the generated random value in the list and stores the sequence numbers of the current symbol. This line creates a scatter plot. The x shows the random values and the y shows the simple count. Sets the graph title to LCG. Labels the y as contents. And labels the x as random value between 0 and 1. Finally, displays the scatter plot on the screen. Okay, run the program. The program generates 1000 random values using the LCG algorithm and displays the scatter plot. We can see that the values are distributed between 0 and 1, showing that the generator is working correctly. Now it's project 6. The objective of this project is to generate random numbers using the LCG formula together with the NumPy library. First, the program imports the NumPy library. It provides mathematical functions. In this project, it's used to calculate the module's operation. This line defines the multiplier used in the LCG formula. Defines the increment value. Defines the modules. It limits the generated values to a fixed range. Defines the initial seed value. It is used to generate the first random number. This loop runs 99 times. During each iteration, a new random number is generated. This line applies the LCG formula. It calculates the next random integer using the multiplier, increment modules, and the previous value of x. This line converts the integer into a decimal value between 0 and 1 by dividing it by the modules. And finally, this line prints each generated random value on the screen. Run the program. The output shows a sequence of pseudo-random numbers between 0 and 1. Each value is generated using the LCG formula and displayed one by one on the screen. Okay. The last one is project 7. The objective of this project is to simulate an MM1Q using independent random numbers streams for arrivals and service times, and then evaluate the system's throughput. First, the program imports queue. It is used as a priority queue to process events in time order. Next, the program imports random. It creates independent random number generators. Finally, the program imports matplotlib to draw the throughput graph. This constant represents an arrival event, departure event, and sets the simulation time to 10,000 events, stores different traffic loads, and stores the throughput results. This line creates the simulation class, and this constructor initializes the simulation and receives two independent random number generators. Creates initializes the simulation clock. Creates the event list. Creates the waiting queue, and this variable records the survey status. Stores the random generator for packet arrivals, and stores another random generator for service times. Using separate generators keeps the two random streams independent. This line sets the arrival rate and sets the service rate. Stores the current traffic load. And these variables record the numbers of arrived, departed, and queued packets. Also stores the total waiting time. This function creates the first arrival event before the simulation starts, and calculates the first arrival time. Inserts the arrival event into the priority queue. This function processes one event at a time. Removes the earliest event from the event list. And this line updates the simulation clock. Starts the current event tab. This line checks whether the current event is an arrival event. If it is an arrival event, the program processes the arrival. Otherwise, the program processes a departure event, calls the departure function. This function generates the inter-arrival time, and this line uses the arrival random stream to generate the next arrival time. This function generates the service time, uses the service random stream to generate the service time. This function processes an arriving packet, calculates the next arrival time, inserts the next arrival event into the event list. This line checks whether the service is idle. This line changes the service status to busy. Calculates the departure time. Schedules the departure event. Otherwise, the packet waits in the queue. Stores the packet in the waiting queue. And finally, this line increases the arrival counter. This function processes a departure event. This line increases the departure counter. Checks whether packets are waiting. Removes the first packet from the queue. Calculates the waiting time. Records the total waiting time. Records one queued packet. This line generates the next departure time. This line schedules the next departure event. If no packets are waiting, the survey becomes idle. This line changes the survey status back to idle. This function calculates the throughput. Calculates the throughput percentage. Stores the throughput result. prints the load and the throughput. This function draws the throughput graph. First plots the graph and sets the graph title, labels the X as load, labels the Y as throughput, and finally displays the graph. This loop runs simulation for every traffic load. This then creates an independent random generator for packet arrivals. And this then creates another independent random generator for service times using different seeds keeps the two random streams independent. Creates the simulation objective and inserts the first arrival event. This loop runs the simulation 10,000 times. Processes one event during each iteration. Calculates the throughput, and finally the program displays the throughput graph. Okay, run the program. The simulation is executed for every traffic load. The throughput values are printed, and finally the throughput graph is displayed. The graph shows the relationship between the traffic load and the throughput. As the traffic load increases, the throughput also increases until the survey approaches its maximum capacity. Okay, that's all. Thank you for your watching.